All right. My recording got corrupted somehow, so I'm going to explain this code that I just got done writing down. Before I was brutally interrupted by, I guess, bad internet connection, I mistaken the hypotenuse and the area for each other for formula, basically because I just got out of a trig class and all that data is in my head. So here we go. So I live typed it earlier. Unfortunately, I don't have the live typing now. So I define it as double hypotenuse, double C. Define this as double because it needs to return it to get the right answer in the hypotenuse. And then I have the area, which was length times width. For some reason, I confused those two formulas, which is funny. And then I did a simple void. Doesn't return anything because that's a void. That's what it means. And it just prints a hello world. These do the math formulas. This one just prints hello world. I define this as static because I want to do it in a non-object oriented way, like C programming. So this is not object orientation. What does that mean? Well, in Java, everything's in a class. The class name is method. Since this is static, that means that it's not an instance of this method. So this is really just one version of this. There's not many versions of this within this class when you make an instance of this method. An example, here is answer that I define, and within area, I have a parameter int a for integer a. I had to fill the parameter, so I said answer, and I know I have to return a value, and it returns the width, which is 10, and the length, which is 4. So 10 times 4, you got 40, and it returns 40. So that's what answer equals. Then I print that onto the screen. And you call this simply just by doing this. But when you're returning a value, you have to say, whatever my variable is, answer equals, call the method. And because there's a parameter, then you fill the parameter with answer. Now on this one, you have the object oriented way. So you got methods. And with these methods, you have an instance, a new instance. So I create a new instance of object, which is instance of method. And then I have a double C, and I defined it as 0.0 to find the hypotenuse. So C equals, and then I had to use this object, call the instance of this method within that object. So object, which is object of methods, instance, which would be double. So hypotenuse, fill the parameter double, and you got it here. And then it will print that. Here the answer was about 10.77, and I used a calculator to check it before. Now on the bottom here, I have a Boolean variable because I wanted to explain how most programs work. So in most real world programs, you will have some type of loop. It'll loop until something ends it. And in a real program, everything would go within a loop, kind of like this. This is usually how I like to write my programs, actually, with these while loops. But, with the while loop, I've used hello world because I wanted to just print hello world. But this one actually prints forever. So I uncomment this counter because I typed in counter plus plus, which I did define up here. In a proper program, one that looks neat, you normally keep all your decorations together. Normally you do. So now I'll add here, and if I run it, it'll just print 5 hello worlds. So it would print 5 hello worlds and everything else. So the area was 40, and then it prints hello world when I just called it once up here. And then when I move down into this while loop, I have it print from 5 times, 1, 2, 3, 4, 5 times. If I get rid of this, it'll print forever. So if I get rid of this, it will print forever. And the reason why I'm doing it again was because earlier I wanted to end it through the Linux terminal, and last time I crashed the program. I want to see if I can guess which one's the right one, even though I really shouldn't have to guess, really. I have a better idea. I'll run it through the terminal and then get rid of it if I can. Let's see. Gotta find the Eclipse folder. Let's see, Eclipse folder. I call it methods, the methods project. I'm going to make a copy on the desktop. I'm going to paste it right here on the desktop. See if I find it. The desktop, there it is. Paste it on the desktop. And now I'm going to use my terminal here. I hold Control C to end the top program, which shows you pretty much it's the equivalent of Windows Task Manager. Although there is a GUI variant on Linux, I just prefer to do it this way. So then I go CD, change directory to desktop. Then I go, oh yeah, that's Windows, LS, list everything. So yeah, that would be Windows. Here, LS would list it. Well, I don't need to do that. So I'm on the desktop, and I already know Javik. See if I remember how to do this. Java. There we go. Then I type in Java, and I should type in methods, and now it's hello world. And now I have a never-ending loop, and I'm doing that on purpose. Like I said, I got rid of the counter on there. Type in top. I'm curious to see if it'll show me as methods on here instead of just that. I don't think it's going to. I know if I kill Java, it will kill it for sure. It will kill it. I want to see if it finds the methods as in method.java. Because the name of the programs would be like on these commands. Oh, I got Java, Java, Zoom, mate, Zorg, and I don't want to kill those. Kill is the command you would type in to end a process on this Linux. I'm using Ubuntu right now. I'm specifically looking for methods to see if it actually pops up so I can get the program instead. I'm not finding it. No. My system D's on here. Interesting. Not surprised. Huh. Not finding it. I was wondering if it was alphabetical. Apparently it's not. That's unfortunate. That would have been cool if I could have showed you guys that. Looks like it can't. Maybe I can kill the second Java thing and see what happens. Because there's two Java things. I don't know which one's which. So Control C, about to find out again because I want to do that. Take out, to do that, you have to type in the specific PID number. Last time I did the first one. This time I'm pressing this one. Let's see what happens. And wow. So for some reason, it isn't very specific for the Java one. So the second one, which is 12.509, I type in kill 12.509. And that stopped this never-ending program. As you saw, it stopped looping infinitely. And my first recording was funny because instead I killed Eclipse instead, which is hilarious. Now I fixed it again by uncommenting the counter. So yeah, that's what I wanted to show you guys. I thought it was pretty cool. So to recap, I just called the main class methods. But, you know, whatever, that was just an example. There's hypotenuse here, which then I did this left to right to pretty much square it. A squared plus B squared equals C squared. So I use this math square root function to return the square root of C, and it returned this. And yes, there is a special way to format it, so you only get 10.77. Actually, I'm going to try float to see if that gives me the right thing or not. I don't know. I doubt it, but we're going to find out. Can we do this? I have to add a cast to float. Of course I do. Add a cast to float. I was just curious to see if I would fix it. Fine, add a cast to float. I don't know why it's telling me I need to add a cast to float on both of those. To me, that makes no sense, since I already defined these as float. Let's take a look. Huh. Now it's undefined. Watch it cry. It's like it's undefined. Maybe if I just define it, it won't complain. Let's see, it says mismatch, double to float. Double to float. Well, C should be float now. It's just saying that's the mismatch. And then it's going to cry and say, oh, it's not been initialized. Gotta love that. I'm just curious about how to fix that, to see what it would have done. I just want to see what float would have done. Well, it makes sense because remember, this has to be defined in order to do the multiplication. So, yeah, it makes sense. Still has an extra, but yes, there is a way to format that. As of now, I don't feel like doing that. I'm just going to return it to double. So it doesn't make a difference. Oh, okay, that can. Oh, yeah. Okay, I guess I can't go that far back. Double. That's kind of lame when you think about it. There we go. Yeah, so floats are smaller, obviously, but there is a way to format this. And so now I don't feel like showing that. But yeah, this is what I wanted to show. Okay. Wish I could have paused it, whatever. So here we go. Inside of that, take a look. Yeah, so static. You basically do this when you want to go the non-object oriented route. There are probably reasons to do this. You know, this is object oriented language. In my opinion, doing this is kind of pointless unless there's a specific thing you need to do, maybe some complex algorithm that you don't want it to be an instance of something. So you may do that, but for the most part, object oriented is a little bit more complicated than this. Like, not only will you be seeing this, but you'll see templates. You'll see classes that run off virtual classes, inherited classes. You'll see stuff like polymorphisms. So there'll be a method, you'll write a base method, and then in your child class, you'll define how that method actually works. So your main class would be maybe a virtual class, and it's just pretty much a blueprint towards all your other classes. So you could do that. And that's how most of the object orientations really work, more so than this. But this is basics. Like you can see the main difference between object orientation, and now you should know how methods work. So, you know, this is just a basic example. I'm thinking that I might shift some of the videos to maybe C or C++ as well, because Java's interesting. And but I really do prefer C and C++. And I'm working on other projects that are somewhat, well, they're C projects. C. Well, I even have some Python projects actually. I just haven't gotten too deep into those projects. Like, actually, I don't even remember how far I got in this project because I had to stop due to school. But we have this that I was working on, and that's just a little bit of something that I'm working on there, but I haven't gotten further with it. And that's supposed to be hit detection blocks, and eventually there's more to this. But right now I'm actually more interested in my other project that I'm working on, and I just have, I have graphical projects. I haven't done anything with this one yet. And that's a bash script. So I got this, and I was just kind of working on this, but as you can see, that's not perfected. It's trying to move it in an arc. It does kind of move, but that code, obviously, there's some error, some bug in this code that makes it that actually it moves it, but it's not supposed to move like that. It's just supposed to move in an arc. So I'm actually kind of glad that I just got done with my trig class, because with my trig, I can figure that one out. Like before that, I wasn't like super attuned to see, like here, and I'm pretty sure this is why that it's doing that, because I'm actually moving this X. I don't need to be doing that. I need to take the shape and just rotate it, but without actually moving it. I'll get back to those two. But anyway, just wanted to show you like what can be done in programming. There's more than just that one single type. Java's cool, but heck, I've even had some web development stuff going on too. But anyway, I guess I'll end this recording. I'll go over some, I think we'll go over arrays. We'll go over arrays, and we'll go over matrices, basically multi-dimensional arrays. And then maybe we'll go over some of my linked list projects that I did just for the heck of it. Anyway, thanks for watching. If you like the videos, just comment, do what you want. It's pretty cool. I'm going to continue updating this as time goes on.